4 questions were asked from the section Trigonometric Ratios and Identities in the January 2024 session of JEE Main Mathematics examination. The aim of this video is to discuss the solutions of these 4 questions in detail. The first question is, this question has appeared in the JEE Main exam held on 27th January 2024 in the first shift. The given question is, let the set of all A belongs to R, the set of real numbers, such that the equation cos 2x plus A sin x is equal to 2a minus 7 has a solution B, the closed interval P comma Q, and R is equal to tan 9 degrees minus tan of 27 degrees minus 1 by cot of 63 degrees plus tan of 81 degrees, then PQR is equal to. We are given the set of all A belongs to the set R, the set of real numbers, satisfying this equation is the interval, closed interval P comma Q, and R is given like this. Then required to find the value of the product PQR. Let's now discuss the solution of the problem in detail. Right. Given the closed interval P comma Q is the set of all solutions of A belongs to R, satisfying this equation cos 2x plus A sin x is equal to 2a minus 7. From this equation, we have to find the bounds for A, or all those solutions which will satisfy this one we have to find. Agreed. Now take that equation, and for cos 2x we write in terms of sin x. That will be 1 minus 2 sin square x plus A sin x is equal to 2a minus 7. Thus we get a quadratic equation in sin x, 2 sin square x minus A sin x plus 2a minus 8 is equal to 0. Now we substitute y for sin x. Then this will become 2y squared minus ay plus 2a minus 8 is equal to 0 is a quadratic in y. And by a simple observation, we see that y is equal to 2 satisfies this equation. So substitute y is equal to 2 in this, then this will be get satisfied. So observe that y is equal to 2 satisfies the equation. That means y minus 2 is a factor. So if a factorization is y minus 2 into 2y plus 4 minus a is equal to 0. These are the two factors. Now from this we want to find the values of A, solutions of A. So second factor is equal to 0 will give you A is equal to 2y plus 4 and y is sin x, 2 sin x plus 4. So the least value sin x takes is minus 1. So the least value A will take is minus 2 plus 4, that is plus 2. And the largest value that the sin x will take is plus 1. So the largest value that this A will take is 2 into 1 plus 4, 6. That means the set of all solutions of A belongs to R will belong to the closed interval 2 comma 6. So A belongs to 2 comma the closed interval 2 comma 6 because sin x will lie between minus 1 and plus 1 for all x belongs to R, including minus 1 less than or equal to sin x less than or equal to 1. Because of this equality only this closed nature has come. This is true for all x belongs to R. So now it is given P comma Q, that is the closed interval P comma Q is the set of all solutions A belongs to R satisfying this equation. Therefore, the closed interval P comma Q is the closed interval 2 comma 6. From this we get P is equal to 2, Q is equal to 6 because we wanted to find PQR. Agreed. Now let us take the next one, that is R. R is given to be tan 9 degrees minus tan 27 degrees minus 1 by cot 63 degrees plus tan 81 degrees. The first step we write is 1 by cot is tan, so we write minus tan 63 degrees. All the remaining things are same. Agreed. For tan 63 we write tan 90 minus 27. For tan 81 we write tan 90 minus 9. Agreed. Now tan of 90 minus 27 is cot 27. Tan of 90 minus 9 is cot 9. Agreed. Now tan 9 plus cot 9, group it, and minus in brackets tan 27 plus cot 27, group it, 27 degrees. Then that will be like this. And tan 9 degrees is sine by cos plus cos by sine. Take the LCM, you will get sine square plus cos square by sine x cos x. And the numerator sine square x plus cos square x is becomes 1. So you will get 1 by sine 90 into cos 90. So also minus, for this also 1 by sine 27 multiplied by cos 27. Agreed. Agreed. For sine 9 degrees, cos 9 degrees, multiply both numerator and denominator by 2. Then 2 by 2 sine 9 degrees into cos 9 degrees, that will be 2 sine x cos x will be sine 2x, that is 1 by 2 by sine 18. So also here 2 by sine 54 degrees. So 2 is taken out and 1 by sine 18 degrees minus 1 by sine 54 degrees. We remember sine 18 degrees, the value of sine 18 degrees and the value of sine 54 degrees. The value of sine 18 degrees is root 5 minus 1 by 4 and the value of sine 54 is root 5 plus 1 by 4. So writing 1 by, so you will get this one. So 2 as it is and 4 is taken common, taken the LCM and simplify. We will get root 5 minus 1 into root 5 plus 1. The LCM is 5 minus 1 and 4 is common in the numerator and that will be root 5 plus 1 minus root 5 minus 1. Minus of minus 1 is plus 1. So root 5 cancels and you will get 4 by 4 cancel. 1 plus 1 is 2. 2 into 2 is 4. So 4. We got R is equal to 4. So R is equal to 4. P is 2. Q is 6. PQR is 2 into 6 into 4. That is 48. So the value of PQR is 48. This is a numeric value type question. Therefore, we have to write down the integer value. So that is 48. So that is the detailed discussion of the solution of the given problem. And it is in a way a simple question. It's an easy question. And I am sure that you have understood. We move to the next question. Right. This question has appeared in the JEE main exam held on 30th January 2024 in the second shift. The given question is for alpha beta belongs to the open interval 0 comma pi by 2. Let 3 times sine of alpha plus beta is equal to 2 times sine of alpha minus beta and a real number k such that tan alpha is equal to k times tan beta, then the value of k is equal to, we are given 4 options. So alpha beta belongs to the open interval 0 to pi by 2 and 3 times sine of alpha plus beta is equal to 2 times sine of alpha minus beta, and there is a real number k such that tan alpha is equal to k times tan beta required to find the value of k. So we'll now discuss the solution of the problem in detail. Right. Given alpha beta belongs to 0 to pi by 2, it is given, and 3 times sine of alpha plus beta is equal to 2 times sine of alpha minus beta. We write down the formulas for sine of alpha plus beta and sine of alpha minus beta. And we are also given a k belongs to the set of real numbers such that tan alpha is equal to k times tan beta. We write down 3 times sine of alpha plus beta is sine alpha cos beta plus cos alpha multiplied by sine beta in brackets 3 times is equal to 2 times sine of alpha minus beta is sine of alpha cos beta minus cos of alpha sine beta. Now 3 sine alpha cos beta minus 2 sine alpha cos beta is tan alpha. 3 sine alpha cos beta minus 2 sine alpha cos beta is sine alpha cos beta. Yes. And 3 times cos alpha sine beta we have sent to the other side. Then we got the other side, we have minus 2 times cos alpha sine beta, and those put together will be minus 5 times cos alpha sine beta. Multiply throughout by cos alpha cos beta. Yes, we can do it. So we do it. So sine alpha by cos alpha is equal to minus 5 times sine beta by cos beta. Thus we get tan alpha is equal to minus 5 times tan beta. Comparing this equation with the given one, tan alpha is equal to k times tan beta, we see k is equal to minus 5. So we look at the answers. So k is equal to minus 5 appears against option 1. So we write down the answer is option 1. Agreed. I make a remark. In all these steps, at no point of time, we have used the fact alpha beta belongs to 0 to pi by 2 except at cos alpha cos beta dividing by cos alpha cos beta. Otherwise, we have not used this result at all, this condition at all. Now, I make a remark. It's okay. People will run through all these things and get very safely the answer given by the examination board. But I make a remark. Is it true? Is tan alpha is equal to k times tan beta, or tan alpha is equal to minus 5 times tan beta? Is it true? I will say, make a remark, right? Now our question is tan alpha is equal to minus 5 times tan beta true for all alpha beta belongs to 0 to pi by 2? No, it is not. Why? Alpha belongs to 0 to pi by 2, the open interval, tan alpha is positive and also tan beta is positive. So a positive is equal to minus 5 times positive. That means a positive is equal to negative, which is not true. So it is not true since tan alpha and tan beta are both positive in 0 to pi by 2. Agreed. So that means this condition alpha beta belongs to 0 to pi by 2 is not the apt one, is not the correct one. But there exists some alpha beta belongs to R such that 3 times of this is equal to 2 times of sine of alpha minus beta. That happens, can be okay. So that means to save this question, I suggest a modification. What is the modification? This phrase for alpha beta belongs to 0 comma pi by 2, the open interval 0 to pi by 2, you replace that by for some alpha beta belongs to R. There exists. some alpha beta belongs to R, a pair alpha beta, there exists at least one, such that this happens, is okay. So, replace the phrase for alpha beta belongs to 0 to pi by 2 in the question by the phrase for some alpha beta belongs to the set of real numbers, then this works. This works, and this will be, the answer is the same. So that is the remark I make, and that is the modification I suggest. Agreed. So that is the detailed discussion and criticism of the given question. Now let's now move to the next question. This question has appeared in the JEE Main exam held on 31st January 2024 in the second shift. The given question is the number of solutions of the equation e power sin x minus 2 times e power minus sin x is equal to 2 is, we are given 4 options. Agreed? So we want to find the number of solutions of this exponential equation given by e to the power of sin x minus 2 times e power minus sin x is equal to 2. Let's now discuss the solution of the problem. The given equation is e power sin x minus 2 times e to the power of minus sin x is equal to 2. Let's call this as the equation 1. Put t is equal to e to the power of sin x. It's an exponential e power sin x. For any value of x belongs to R, e power sin x is always positive, thereby t greater than 0. So note that t greater than 0 for all x belongs to R. Agreed. Now the equation 1 will become, because you are putting t for e to the power of sin x, then equation 1 becomes t minus 2t inverse is equal to 2, and this becomes the exponential, the quadratic equation t square minus 2 is equal to 2t, and thus we get a t square minus 2t minus 2 is equal to 0. Solve for t using the formula, simplify, you will get the two roots for t is 1 plus or minus root 3. Now if you take 1 minus root 3, root 3 is a bigger root 3, the value of root 3 is more than 1. So 1 minus root 3 will be negative. Can t be negative? No, t is positive for all x belongs to R. Therefore, that's not possible. As t greater than 0, we reject t is equal to 1 minus root 3 because 1 minus root 3 is negative and t is positive for all x belongs to R. So, t value will be 1 plus root 3. What is t? E to the power of sin x. So this will imply e to the power of sin x is equal to 1 plus root 3. Agreed. Now, let us look at sin x, and it varies between minus 1 less than or equal to sin x less than or equal to 1 for all x belongs to R. And e power x, the exponential function, is a strictly increasing function. Therefore, e to the power of minus 1 less than or equal to e to the power of sin x less than or equal to e power 1, that is e, for all x belongs to R. Agreed? Agreed, agreed. Now, assume for some x belongs to R, we have e to the power of sin x is equal to 1 plus root 3. That means we suppose that this equation e to the power of sin x is equal to 1 plus root 3 has a solution. So let's say that is for some x belongs to R, this happens. So that will be equal to, now look at this carefully, 1 plus root 3 is equal to e to the power of sin x, and e to the power of sin x is less than or equal to e. Yes. That means it tells you 1 plus root 3 is less than or equal to e, which is not true. Why? 1 plus root 3, the value is 2.73, and the value of e is 2.72 approximately. So 2.73 is less than or equal to 2.72 is not possible. Therefore, there is no such x belongs to R such that e power sin x is equal to 1 plus root 3. And 1 plus root 3 is less than or equal to e is not true, because 1 plus root 3 is approximately equal to 2.73 greater than the exponential e, that is approximately equal to 2.72. That is 2.73 is greater than 2.72 is the fact, but here you got 1 plus root 3 is less than or equal to e. Therefore, this is not true. So there is some x belongs to R for such that this happens is not true. Therefore, for no x belongs to R, e power sin x is equal to 1 plus root 3. That means this equation, this given equation, has no solution in the set of real numbers. So the answer, the number of solutions of this equation is 0. So let's look at our options. Our option that this equation has no solutions appears against option 1. Therefore, the answer to this question is option 1. Agreed. So that is the detailed discussion of this solution of this question. I am sure that you have understood the solution of this problem. We will move to the next one. Right. So this is the last question in this discussion. This question has appeared in the JEE Main exam held on 1st February 2024 in the first shift. The given question is, if tan A is 1 by root of x multiplied by x square plus x plus 1, tan beta is root x by under the square root of x square plus x plus 1, tan C is in brackets x to the power of minus 3 plus x to the power of minus 2 plus x to the power of minus 1 whole to the power of 1 by 2, where 0 less than or less than 0 less than a b c less than pi by 2, a comma b comma c less than pi by 2. So that means each of these lie between 0 to pi by 2. That means each of this a b c belongs to the open interval 0 to pi by 2. Now then the question is, a plus b is equal to, we are given 4 options. Agreed. Let's now discuss the solution of the problem in detail. So for your ready reference, tan A, tan B, tan C values are given here. So we will compute now tan of A plus B. Use the formula tan A plus tan B by 1 minus tan A tan B. For tan A, we write 1 by root of x into x square plus 1. For tan B, we write down root x by root of x square plus 1. Agreed. In the numerator, take the LCM. The LCM will be under the square root of x into x square plus x plus 1. The numerator will become 1 plus x. In the denominator, 1 minus root x by root x cancels. Root of x square plus 1, root of x square plus 1 will become x square plus x plus 1. That means 1 minus 1 by x square plus x plus 1. That will be the situation in the denominator. So that's what we have written here. And in the denominator, take the LCM. So if you take the LCM, x square plus x plus 1 minus 1 by x square plus x plus 1. 1 cancels. Then this will be a by b by c by d. We normally write is a by b multiplied by d by c. So like this. And x square plus x is x into 1 plus x. 1 plus x cancels. X will remain here. Right. So that is written here. 1 plus x cancels. X will remain root x root x. And root of x square plus 1, root of x square plus x plus 1 cancels with root of x square plus x plus 1 times in the numerator. So you will have root of x square plus x1 plus 1 by x root x. and this is x root x is x cube to the power of 3 by 2. So that will be under the square root of x square plus x plus 1 by x cube. Separate them. X square by x cube plus x by x cube plus 1 by x cube. That will be under the square root of 1 by x plus 1 by x square plus 1 by x cube. Right. Take the LCM. So that is, write down like this. X to the power of minus 1 plus x to the power of minus 2 plus x to the power of minus 3 whole to the power of 1 by 2. Let's look at here. Here tan c is precisely this one. So this is equal to tan c. So thus we have proved tan of a plus b is equal to tan of c. Now we are asked to find, so let's look at our options. If 0 less than ABC, a comma b comma c less than pi by 2, then a plus b is equal to 4 options are given. Now I will read out these options. So I will test one after the other which one of them is true. This is what I say is by elimination I will find out the correct answer. Right. Suppose that option 1 is true. That is a plus b is equal to 2 pi minus c. Then tan of a plus b will be equal to tan of 2 pi minus c. Tan of 2 pi minus c is minus tan c, and which is not true. Tan of a plus b is tan c, which is, this is, you are getting a different one. Therefore the option 1 is not true. By a similar argument, you can, these options also can be eliminated. So by a similar argument, options 3 and 4 are not true. Therefore option 2 is true. Therefore a plus b is equal to c. Agree? So your answer to this question is option 2. So that is the detailed discussion of this problem. And thus we have now come to the end of the discussion of the 4 questions from the trigonometric ratios and identities that have appeared in the JEE Main January 2024 session. I am sure that you have understood the solutions of these 4 questions and their solutions, and I wish you all the best. Thank you.